Hi guys, this is Ms.Hong. Today is June 12th, Friday. It's Friday. Happy Friday, guys. And we have literally like one more week left because our last day of school will be June 23rd, right? It's next Tuesday, so next week you will have NWEA test for the final, and 18, 19 I'm gonna give you my final, and 22 and 23 you will make up all the missing work because creating due is June 23rd. All right, so literally we're almost done. So I just want to let you know next Tuesday, which is June 16th, you should take NWEA test, which is, do you remember that at the beginning of the year it's about 52 to 53 problems, and if you get number 1 correct, number 2 gets a little harder, and you get it wrong, then test level gets a little like easier, like that one. So basic math, we just want to see how much you grow, so at the beginning of the year and at the end of the year. Okay, so I'm gonna post like more detail about that test, and let's go. Today we will do this, rewriting expressions using properties of exponents. You know what, guys? You don't see my hand, right? Because I figured it out. So now I'm not showing my hands, but I can still write it. Hello. Like this, right? It's cool. Why did I figure out like at the end of the year? I should figure that out at March, right? But anyway, I'm getting like better every single day. All right, guys, look at this. Part A. Do you think the following statements are true or false? Explain your reasoning. Talk to a partner. I don't have partner, so I'm going to talk to you guys. So this one, we're figuring out that's true or false, right? So look, 2 to the 2x and 4 to the x. We're comparing this two, right? And you know what? By power to the power, then we can multiply it, right? So for this one, 2 to the 2x, can I make it this? Then you can make it power to the power. That's same as that one, right? You can just put the parentheses for that. Then look, inside of the parentheses, that will be 4. 2 squared, which is 4. So that's 4 to the x. So what? Same thing. So this is true. And the second one, we can do the same thing again. So 4 squared to the x power. So for that one, I can do parentheses like this, right? And just calculate the inside, then you get 16. So 16 to the x, which is this. So this is also true. But what about this? 3 to the 3x. Then when we do the same thing, what's 3 cubed? It's not 9, that's 27. So that's 27 to the x. So they cannot be the same. So this is false, right? And the last one, so we did the radical, right? Your index number is 4. So I can do it 5 to the 1 over 4 to the x power. Oops. And 1 over 4 to the x power, right? And then this one, power to the power. You can multiply it, right? So 5 to the x over 4. So you get the same thing. So this is true, right? So like using all the properties and you're solving problems. So this is like PARC test, like NJSLA test. Because of pandemic, we couldn't take the NJSLA, but you're supposed to do this kind of stuff, right? And part B, which equations are true for all values of x? So it's the same thing. It's same as like those kind of thing. It's the same thing, all right? Those kind of work. So let's look at A, guys. Let's look at A. And look, you have subtractions on the power, 2 minus x power. Then when we break it, then you need to divide it, not subtracting it. You need to divide it. 3 to the 2 minus x, that's same as 3 to the second power divided by 3 to the x, right? So this is not right. And B, 3 to the x plus 2, right? Then look, minus, then we divide it, plus, then we multiply it, right? So we can rewrite it, 3 to the x power times 3 squared. Make sense? Right? If you're not sure, then you can have our lesson right next to you and look at the property, all right? And then, guys, look, this is what? 3 to the x, and what's 3 squared? That's 9, right? So can I just write it 9 times 3 to the x? It's the same thing, right? So this is true. And C, obviously that is true, right? Because 3 to the x squared, and that is power to the power. So you multiply it, 3 to the 2x, right? And then from here, we can just put the parentheses for that, like this, right? So that's the same thing. You can switch this too, because that's multiplication anyway. So that is true. And what about D? It's 9x plus 2 power. And guys, you know what? When you look at this, you have 9 and 3, right? So something related to 3. So 9, because we know 9 is 3 squared. So I'm going to write 3 squared for 9. Instead of 9, I wrote 3 squared. And x plus 2 power, right? Then guys, look. This one, power to the power, right? Power to the power. So I will multiply this. Then 3 to the 2x plus 4, right? 2 times by x, 2x, 2 times by 2, 4, right? Then look, it's the same thing. Same thing over here. So this is also true, right? And guys, look at this. 27 to the x power. Is that same as 3 to the x power cubed? Let's see. 27. What's 27, guys? 27 is 3 cubed, right? So 3 cubed to the x power. And like this property, guys. Where is it? Like this. This one. Like this one. I'm going to use the same property like that. Look at this. Compare that. X and 2. 2 and x. You can switch the order, right? So from here, I can also do that. 3 to the x, 3. Like this. You can change this 2. This 2. Right? So this is also true. And the last one, F. So this is about radical, right? Fractional, rational exponent. So look, this one, nothing here. That means 2, right? So we can do 5 to the half. And this one, you have 3 here. So it is 5 to the 1/3, right? And you know what? 5 to the half, 5 to the 1/3. Then what? We can add it because you got the same base and product. So this is 5 half plus 1/3, right? And guys, half plus 1/3, your common denominator will be 6, right? And then, you know, like cross product, then you get 3 plus 2. So it will be 5 over 6 power. So this is also true. Oh, except A, everything was correct, right? So please go over your work, all right? And this is confusing. I know that. This is confusing. This is not easy. Many people struggling on this one, guys. But you practice more, you get it more. You get it better. And part C. So look at this one, guys. Consider the original expression, this. And rewrite this expression as a times by 3 to the x, right? So let's do it. I'm gonna rewrite my question over here. So when I look at this, all I can do is simplifying this part. Because for that one, we can do anything more. That's it, right? So I'm gonna simplify my second part, 3 to the x. This is, I just copy it, and minus this one. Because you have addition on the power, we can break it into product, right? And then, guys, look. Do you see the common term? 3 to the x and 3 to the x, right? So that is your GCF. So I'm gonna factor by my GCF. So 3 to the x, you factor it by, then what? 1, right? Because you took out this entire thing. Then leftover will be 1, because, right? Nothing means 1. So you have 1 here, and minus, you just follow the sign. And 3 to the x, you take out that one over here, right? So you're left over 3 to 3 squared, like this, right? Then that is 3 to the x, 1 minus 3 squared, which is 9, right? And guys, look, 1 minus 9 is negative 8. So this is negative 8. Can I just write it negative 8 times 3 to the x, right? So look, we got the answer. 8 times 3 to the x, that is negative 8 times 3 to the x. That's the same thing. A times 3 to the x, that is same as negative 8 times 3 to the x. So your A is equal to negative 8. Okay, so my A equals negative 8. This is my solution. Okay, so guys, tomorrow, no, Monday, I'm gonna upload your homework, something similar to this one. All right, so you can figure out that's like this equation is true or false. So you need to convert one side to the others. So if you see any properties, then apply it, all right? And part C could be hard. This one is hard, but from here you simplify, or just use your properties and combine the GCF, then you will end up with the solution. Okay, all right guys, so that's it for today and our lesson quiz for today. Do you see Ms. Hong's hand in the video? Yes or no? You never see it because I figured it out, right? So please answer the question correctly. And you have great weekend, guys. And John, nice to meeting you in the street. Bye, guys.